Hello and welcome to this ninth set of problems on arithmetic progression, geometric progression, and harmonic progression. In this set, we will solve problem number 81 to 90. And as always, I will say that when I am stating the problem, you should pause the video. And if you cannot solve the problem yourself, only then look at the solution. So without further ado, let's get started. Problem number 81 says that if Sn denotes the sum to n terms of a GP whose first term and common ratio are A and R respectively, then prove that S1 plus S2 plus up to Sn is equal to Na by 1 minus R minus AR into 1 minus R to the power n by 1 minus R whole square. So S1 would be A. We can rewrite this as A into 1 minus R by 1 minus R. S2 would be A plus AR. We can rewrite this as A into 1 minus R squared by 1 minus R. S3 would be A into 1 minus R cubed by 1 minus R. And similarly, we have the formula for nth term, that is Sn is equal to A into 1 minus R to the power n by 1 minus R. Now we add all this. So we take out the term which is common in all these, which is A by 1 minus R. When we take this, what remains is 1 plus 1 up to n terms. And then we take out AR by 1 minus R common. What remains in the brackets is 1 plus R square up to R to the power n minus 1. Now this is a GP with common ratio R and first term 1. So applying the formula, we arrive at the final result, which is Na by 1 minus R minus AR into 1 minus R to the power n divided by 1 minus R whole square, which is what is required from us. Problem 82 says that if Sn denotes the sum to n terms of a GP whose first and common ratio are A and R respectively, then prove that S1 plus S3 plus S5 up to S2n minus 1 is equal to Na by 1 minus R minus AR multiplied with 1 minus R to the power 2n divided by 1 minus R whole square 1 plus R into 1 plus R. So here first term is the same as the previous problem. S3 would be A into 1 minus R cubed by 1 minus R. S5 would be A into 1 minus R to the power 5 by 1 minus R. And S2n minus 1 would be A into 1 minus R to the power 2n minus 1 by 1 minus R. So everything else remains same. What changes is over here. The geometric series now is 1 plus R square plus R to the power 4 up to R to the power 2n minus 1. This is with common ratio R square. So the sum of this would be 1 minus R to the power 2n divided by 1 minus R square. So this should be 1 minus R. So here we will have 1 minus R square and then 1 minus R would be there. So this term will change to 1 minus R whole square into 1 plus R. And in the numerator it will become 1 minus R to the power 2n according to the formula. Problem number 83 says that let S denote the sum of terms of an infinite geometric progression and sigma square the sum of square of the terms. Show that the sum of first n terms of this geometric progression is given by S into 1 minus S square minus sigma square divided by S square plus sigma square whole to the power n, where modulus of R is less than 1. So S is A by 1 minus R and sigma square is A square by 1 minus R square, and Sn is A into 1 minus R to the power n by 1 minus R. So our given expression becomes, which is, the given expression is S into 1 minus R, and then we have S square minus sigma square divided by S square minus sigma square whole to the power n. So we substitute for S, we get A by 1 minus R here. We substitute for these two over here. So we get A square by 1 minus R whole square minus A square by 1 minus R square. And similarly in the denominator we have plus. So you see A square will get cancelled. 1 minus R will get cancelled. Over here it will be 1 minus R. Over here it will be 1 plus R. So we have this. And now if we evaluate this entirely, it will become 1 minus R to the power n. So the final value is a by 1 minus r into 1 minus r to the power n, which is equal to SL. Problem 94 says that let a1, a2, a3, an be a geometric progression with first term a and common ratio r. Then the sum of the products a1, a2 up to n taken two at a time is sigma ai aj, where I is less than j, is equal to a square r 1 minus r to the power n minus 1 into 1 minus r to the power n divided by 1 minus r whole square into 1 plus r. So you might remember from the cyclic equations in your earlier classes that sigma aiaj by aiaj, where I is less than j, is equal to half. In the brackets we have a1 plus a2 up to an whole square minus a1 square plus a2 square plus up to an square. So the first part of this, that is this, it becomes a plus ar plus up to ar to the power n minus 1 whole square, and this becomes a square plus a square r square plus up to a square r to the power 2n minus 1. So if you evaluate this, this becomes 1 by 2 into a square 1 minus r to the power. There is something wrong here. So what is wrong, I'll tell you. So this becomes a square 1 minus r to the power n whole square divided by 1 minus r square, and then this, the second part in the brackets, is minus a square into 1 minus r to the power n by 1 minus r square. This is written properly in the next line. So this becomes 1 by 2 and a square into 1 minus 2r to the power n plus r to the power 2n divided by 1 minus r whole square. This becomes a square into 1 minus r to the power 2n by 1 minus r square. Now all remains is taking LCM and solving, which will yield us our desired solution. Problem 85 says that if a1, a2, a3 is a GP with first term a and common ratio r, so that 1 by a1 square minus a2 square plus 1 by a2 square minus a3 square plus up to 1 by an minus 1 square minus an square is equal to r square multiplied with 1 minus r to the power 2n minus 2 divided by a square r to the power 2n minus 2 multiplied with 1 minus r square whole square. So our left hand side is this much. So we take out in the common terms, that is a square multiplied with 1 minus r square. What remains inside is 1 plus 1 by r square plus 1 by r to the power 4 up to 1 by r to the power 2n minus 2. So we see that this is a GP with common ratio 1 by r square. So we evaluate this and we solve further to get the desired solution. Problem 86 says that if a1, a2, a3 and so on is a GP with first term a and common ratio r, so that 1 by a1 to the power m plus a to the power m plus 1 by a2 to the power m plus a3 to the power m and so on up to 1 by n minus 1 to the power m plus an to the power m is equal to r to the power mn minus m minus 1 divided by a to the power m into 1 plus r to the power n multiplied with r to the power mn minus m minus r to the power mn minus 2m. This is similar to previous problem. It just looks difficult, but it is a very easy problem. So left hand side becomes 1 by a to the power m. Now this one is a2 to the power m. a2 would be ar. So it is a to the power m, r to the power m. And then in the second term, we have 1 by a2 to the power m, which is equal to a to the power m, r to the power m, like previous one. And then we have a3 to the power m, which would be a square whole to the power m, that is equal to a to the power m, r to the power 2m. And similarly, we have reached this, which is a n minus 1 to the power n. A n minus 1 would be a r to the power n minus 2. So the entire thing is raised to the power m. And similarly, this is a n minus 1 to the power m. Now, if you observe this entire series, we can take a to the power m into 1 plus r to the power m common. If you take this much common, what remains inside the brackets is a geometric series, and this should be 1 by r to the power m minus n minus 2. This is not in the numerator but in the denominator. So what remains inside bracket is a geometric progression with common ratio 1 by r to the power m. So now we apply the formula for the sum and we solve to get the desired answer. Problem 87 says that if a1, a2 up to a2n are 2n positive real numbers which are in GP, show that the square root of a1, a2 plus square root of a3, a4 plus square root of a5, a6 up to square root of a2n minus 1, a2n is equal to square root of a1 plus a3 plus up to a2n minus 1 multiplied with a2 plus a4 plus up to a2n. So we first take left hand side. Our expression becomes square root of a square r plus square root of a square r5 plus square root of a square r9. If you see a1, it is a, and a2 would be ar, so a square r. a3 would be ar square, and a4 would be ar cube, so it is a square r to the power 5. And similarly, this would be a square r to the power 9. That is what is written here. Now we take a outside and square root of r outside. So what is inside the brackets is a geometric progression with common ratio r square. So this becomes a square root of r to the power 2n minus 1. This should be minus 1 over here, not in the power, divided by r square minus 1. Similarly, when we take the terms of right hand side, the first term becomes in a similar way equal to a into r to the power 2n minus 1 by r square minus 1. And then the other term becomes square root of a square root of r to the power 2n minus 1 by r square minus 1. Again, this should be minus 1 over here, not in the power, it is all by typo. So now these two are multiplied and we can take out a square root of r outside. And when you take that outside upon multiplication, then you get the desired result. Now we move on to next problem. Problem 88 says that find the solution of the system of equations 1 plus x square up to x to the power 23 is equal to 0, and 1 plus x square plus up to x to the power 19 is equal to 0. So we can write this as x to the power 24 minus 1 by x minus 1 is equal to 0, and this as x to the power 20 minus 1 by x minus 1 is equal to 0. So x minus 1 will get multiplied with 0 in both the cases, and we will have x to the power 24 minus 1 is equal to 0 and x to the power 20 minus 1 is equal to 0. Now from the second equation, we observe that x to the power 20 is 1. So the first equation we rewrite x as x to the power 20 into x to the power 4 minus 1 is equal to 0, and we substitute x to the power 20 is equal to 1. So this becomes x to the power 4 minus 1 is equal to 0. Now x to the power 4 minus 1 is equal to 0 means x square minus 1 into x square plus 1 is equal to 0. X square minus 1 will give us minus 1 and wait a minute. So x square minus 1 and x square plus 1 is equal to 0. So x square plus 1 would be x square is equal to minus 1. So x would be square root of minus 1. So that will give us plus minus I. And x square minus 1 would be x square is equal to 1. So that will give us plus minus 1. But x cannot be plus 1, because if x is plus 1, then this entire thing would be 24. It will not suit the expression. So x has to be minus 1. So the roots are minus 1 and plus minus I. Problem number 89 says that a man invests $A at the end of first year, $2A at the end of second year, $3 at the end of third year, and so on up to the end of another year. If the rate of interest is $R per rupee and the interest is compounded annually, find the amount the man will receive at the end of n plus 1 year. So $A will become A plus R into A, that is A into 1 plus R at the end of second year, because this amount is invested at the end of first year. And then at the end of third year, this amount will become A plus AR, which is at the beginning of third year, multiplied with r into a plus ar, which is a plus 2ar plus ar square, which can be written as a plus a into 1 plus r whole square. Similarly, at the end of fourth year, according to calculation here, it would become a into 1 plus r whole cube. So the amount received for $A after n plus 1th year would become a into 1 plus r to the power n plus 1. This is in line with compound interest, which you have studied in earlier classes. Just that divided by 100 is not there because r is not in percentage. So according to compound interest formula, we could have straight away written that the final value of $A would be a into 1 plus r to the power n plus 1. Now 2a is invested at the end of second year. So a will become 2a, but n plus 1 will become n. So the amount received for 2a dollars would be 2a into 1 plus r to the power n. And for 3a it would be 3a into 1 plus r to the power n minus 1, and so on. For the amount NA invested, which would be invested at the end of nth year, we will have only 1 year. This would be NA into 1 plus r. Now we divide this s by 1 plus r, and we obtain the series a into 1 plus r to the power n plus 2a into 1 plus r to the power n minus 1, and so on up to n minus 1 into 1 plus r plus na. For na, this 1 plus r will get cancelled. Now we write the first term of this second series below the second term, and this 2a second term below the third term, and then we subtract. So what we will obtain is rs by 1 plus r is equal to a into 1 plus r to the power n plus 1 plus a into 1 plus r to the power n plus a into 1 plus r to the power n minus 1, and so on. And in the end, we will have minus na. This na would become over here in negative term. So we see that we take out 1a into 1 plus r outside. So we will have a geometric progression inside, which would be 1 plus r to the power n plus 1 plus r to the power n minus 1 up to 1. And then we will have minus na. So we now can apply the formula and take out to 1 plus r and r from left hand side and take it to the right hand side. We will have the final solution as a into 1 plus r whole square into 1 plus r to the power n minus 1 divided by r square minus na into 1 plus r divided by r. Problem number 90 says that find the value of 0.16 to the power log of 1 by 3 plus 1 by 3 square plus 1 by 3 cube plus infinity, where base is 2.5. So we first find the sum of this infinite series, which is half. So we can rewrite this as 4 by 25 to the power log of 5 by 2, log of half with base 5 by 2. 2.5 is 5 by 2, 0.16 is 4 by 25. So now we can exchange the logarithm and the base on which the power is 8. We can rewrite this as 1 by 2 into log of 4 by 25 with base 5 by 2. This comes from the logarithm. So once we have this, we observe that 4 to the power 25 is 1 by 5 by 2 whole square. So this entire thing becomes half to the power minus 2, which is equal to 4. This involves the concept of logarithm. If you know logarithm, then it is a simple problem, otherwise you just can't solve it. So we will study logarithm next after we finish arithmetic progression and these miscellaneous problem series. So with this, we come to the end of this problem set, and in the next problem set, we will solve problem number 91 to 100. So if you have found this video useful and informative, please like the video and subscribe to the channel, because that will motivate me to make more such videos, and it will also make sure that the video reaches to more audience and more people get benefit from this. If you have a question or suggestion, you can give me information about that in the comment box. So cheers, enjoy.